Yes, my dear student, now the law of gases, Boyle's law, was given by the Robert Boyle in 1962 at the constant temperature. He was explaining that volume is inversely proportional to pressure. So, volume is equal to K by P. So, this equation becomes PV is equal to K. From this, we will get the relation P1 V1 is equal to P2 V2. In this one, P1 by P2 is equals to V2 by V1. Out of these four terms, three terms will be given to you, and one term you have to find out. And this is applicable, and from this law, whenever he is drawing the graph, one is increasing, one is decreasing. Simple graph is coming in this way. If volume is decreasing, pressure is increasing. If we will take 1 by V versus P or 1 by P versus V, this graph will go in this way. And if PV is constant, then putting versus P or V, then again straight line constant. And if we will take the graph in this way, suppose that at V1 the pressure is P1, and at V this is V2 and then it is P2, and this is V1 and this is P1, then again he is joining and getting a straight line. And the next, the importance of Boyle's law in our life. From this law we came to know that gases are compressible. Gases are compressible, and one more thing, that when with increasing in the height, we are going to high altitude, the pressure is decreasing and volume is increasing. That's why balloon will get burst. Because of that, volume will be increased. And this law is only proving that gases are compressible because the density of gas is directly proportional to pressure. And we know that volume is inversely proportional to pressure and pressure is directly proportional to density. So the density of gas is directly proportional to the pressure. At high altitudes, the pressure is low. The density of air will be low on the mountains. So mountaineers have to carry the oxygen cylinder to avoid the respiratory problem. So this one are the uses of the Boyle's law. And next law is what? That is the Charles law. Now the second law is what? Charles law, given by the Jacques Charlet in 1787. He states that at pressure constant, volume is directly proportional to temperature. So V is equal to Kt and V by T is equal to K. From here we will get the relation V1 by T1 is equal to V2 by T2. Graphical representation, V versus T direct line, or V by T versus T, then again it is in constant. And the significance of Charles law, you know very well that density is equal to mass by volume, and density is inversely proportional to volume. So, but volume is directly proportional to temperature at pressure constant. So finally, what? Density is inversely proportional to temperature. So when the density of gases decreases, means of that density of gases decreases upon heating. That is, hot air is lighter than atmospheric air. And with this one, I would like to discuss that absolute zero, that is the 0 Kelvin or minus 273.15 degrees centigrade. It is the lowest possible temperature at which the volume of gas is supposed to be zero. Lowest possible temperature where the volume of where the volume of gas is supposed to be zero. Before this, supposed to be zero. Below this temperature, volume becomes negative. Below this temperature, volume becomes negative, which is not possible. By graphically, we can see this one. This is volume, this is 0 degree, and then temperature T degree centigrade. Suppose this is minus 100, minus 200, and this is what I am representing, minus 300. And we draw the graph. This graph stand by at here, that is the minus 273 degree centigrade, which touches the 0, and before that volume get negative, which is not possible. So my dear student, take this one, and this is important. And one more, that is improved form of Charles' law. That is what he was saying, that Vt total volume is equal to V0 plus V0 by 273 of any 1 degree rise or fall in temperature. So this is the improved form of the Charles' law. From here we can also get a relation. Vt by V0 is equal to Tt by T0. Numerical can be asked, and take care. Now coming on the third law of the gases. Now Avogadro law. Avogadro was states that equal volume of gas contains equal number of molecules under the same conditions at the pressure and temperature. So V is equal to what? Kn, and V by N is equal to K. This is very important law. And then next is that Gay-Lussac law. Gay-Lussac law. Amanton's law. It states that keeping the volume constant. In Gay-Lussac law, keeping the volume constant, it states that keeping volume constant of given mass of gas, the pressure is directly proportional to temperature. Means that whenever the volume is constant, pressure is directly proportional to temperature. Then P is equal to Kt, and P by T is equal to K constant. Here we are getting the relation P1 by T1 is equal to P2 by T2. And this one we can feel that the tire of the bus or the car volume is constant. In the morning it is tight, but in the afternoon when the temperature is rising high, it get inflated. Now in the next class we will discuss the ideal gas equation by combining all these laws. Goodbye student, bye bye.